You smell that? That's the smell of fresh, fresh printing paper, freshly printed from my Brother Black and White. I don't know the model number. It's a good printer. Highly recommend. We are doing section. This is going to be W.13. You guys thought I was done? Yeah, right. We still got a few more of these to get going, so you guys can have something to maybe review on Monday, because I don't want you guys to be bored doing all this on Monday. We have a polynomial divided by a monomial. Monomial meaning one term, and polynomial meaning more than one term or any number of terms. In this case, it's going to be two terms. So we have a 28s to the power 2 plus 8s, all divided by 4s. The way that we do these is we're just going to put each term separately. We're going to put it all over 4s. This is exactly the same as 28s to the power 2 plus 8s over 4s. You can separate out the numerators, the top numbers, as long as you keep the denominator underneath both of them. So we're going to do these kind of like one step at a time. We have 28 over 4, 28 divided by 4, that's going to give us a 7. We have two s's on top, we have one s on bottom. So this is what it's going to kind of look like. We have s to the power 2 over s. It is the same as s times s over s. So one of the s's on the bottom can cancel with one of the s's on top. We are left with one s on top. So that's going to be 28 over 4 is 7. S to the power 2 divided by s is s. And we have this plus, let's do this in maroon, plus 8 divided by 4 is going to give us a 2. S divided by s, the s's cancel out. So we're just left with this 2. So the whole answer is going to be 7s plus 2. Incredible. Now we are given a slightly more complicated one, a negative 30y to the power 3 plus 35y squared to the power 2 divided by 5y to the power 2, 5y squared. So we're going to do that, divided by 5y squared. I'm going to put that same denominator under both terms. And negative 30 divided by 5 is going to give me a negative 6. We have y to the power 3 over y to the power 2. If we expanded that, that would look like this. Y times y times y over y times y. So we can see one y cancels with one y on the bottom and top. We have one y on the bottom, cancels with one y on the top. And all we have left is this single y. So there's a y there. Why do this problem? Why do anything at all? It's really the answer that I don't know yet. Hopefully you guys do. Why do we do anything? Because Mr. Bennett told us to. Let's go. If you guys are doing anything because I said, that is probably the wrong motivation. But for the record, I do want what's best for you guys. So most of the time, the advice that I give you guys is probably pretty good advice to follow in your life. Anyway, we have a y to the power 2 on top is going to be canceled by the y to the 2 on bottom. So we're just left with 35 divided by 5 is 7. And that's going to be our answer here. Would you look at that? Now, this is probably the most complicated one. We have a 56z to the power 3. Perhaps my favorite letter. Something about z's that are just really... Oh, I don't know why I put... Oh, no, there's a 49 there. Plus 49. And then we're going to divide each one by 7z. 7z and 7z. Okay. Now, we can do the numbers pretty easily. We can see 56 divided by 7 is going to give us an 8. 42 divided by 7 is going to give us a 6. And 49 divided by 7 is going to give us a 7. That's what the coefficient part is going to be. Now, the difficult part is what are we going to do with these z's now? Well, we've got a z to the power 3 over z. That's going to give us z times z times z all over 1z. So one of the z's on bottom cancels with one of them on top. We're left with 2 z's on top. So it's going to be z to the power 2. In the second term, the z's just cancel out, so we're just left with a 6. And this third term is interesting because we have this 49 and this 7 give us a 7 on top. We have 0 z's on top and 1 z on bottom, so we have 1 z on bottom here. Let me give you another example. Maybe this will kind of solidify it. Let's say we have a 36 r to the power 2 over r to the power 5. Now let's do a 6 r to the power 5. What would this equal? Well, the top and bottom, we've got 6. 36 divided by 6 is going to give us a 6. We have 2 r's on top and we have 5 r's on bottom. 2 of these r's on top are going to cancel with 2 of them on bottom. So we're left with 3 on the bottom. So this would give us 6 over r to the power 3. And one more, just for bonus, because I know you really are clamoring for it. By the way, this is our answer here. One more bonus question, perhaps we would like this, is we have a 30 z to the power 2 plus 10 z plus 5, all divided by 20 z to the power, let's say 4. Okay, so what would this look like? We got 30 z to the power 2 divided by 20 z to the power 4 plus 10 z divided by 20 z to the power 4 plus 5 over 20 z to the power 4. If you want to challenge yourself and try to do this, pause the video. But if you are like most students and do not heed my advice, I will just do this because you're going to wait for the answer anyway. So we have a 30 divided by 20. If we need to simplify this, this is really 3 times 10 times z times z. You see how 30 z to the power 2 is 3 times 10, which is 30, times z over. And how can we break this 20? We can break it into 2 times 10 times z times z times z times z. These two are the same. We just broke it down into smaller parts. Plus 10, we could just say it's 10 times z over 2 times 10 times z times z times z times z. And we could do this one as a 5. Oops, I want to do that in maroon, but I already did in black. Times 2 times 10 times z times z times z times z. Actually, we probably don't want to write this as 2 times 10. We can write this instead as a factor. How can we write 20 as with a factor of 5? We can write it as 4 times 5. 4 times 5 is 20. So you see, this is the same 5 on top, 20, which is 4 times 5 times z times z times z. Over here, it's 10 times z on top. 2 times 10 times z times z times z, which is 20. 2 times 10 times z times z times z is 20. 3 times 10 is 30. Okay, what can we cancel out? What's the same on the top and the bottom? Well, we have this 10 can cancel with this 10. This c can cancel with this c, and this c can cancel with this c. We've got this 10 can cancel with this 10. This z can cancel with this z. And we've got this 5 cancel with this 5. So what is our answer going to look like all together? Well, we're going to have this 3. What's on top now? Just the 3 over 2z to the power 2. See that the 10s, the z, and the z cancel? Plus, well, we have nothing on top, and we have 2 times z times z times z, which is z to the power 3. I should write that as z to the power 3. If we have nothing left in the numerator, we're going to write a 1 as a placeholder. Fractions are kind of weird. Let's just call it like that. And same over here, we've got this 5. This 5 cancels out. We get 4. And we have 1, 2, 3, 4 z's on the bottom. So z to the power 4. And we have nothing on top, so we're going to write a 1. So this would be the answer to this question. And hopefully that helps you a little bit with dividing monomials. Stick around, we got more videos to come.